we're going to use a graphing calculator and the change of base formula to graph and find the points of intersection for a logarithmic and exponential function that are known to be inverses. If there is more than one point of intersection, we're going to report the one with the larger x value. So in this example, we have f of x equals the log base a half of x minus 3, and g of x equals 1/2 to the x power quantity plus 3. So looking at f of x has been replaced by x minus 3. So the vertical asymptote will be at x equals 3. Because the base is a half, and a half is between 0 and 1, it is a decreasing logarithmic function. When we look at g of x, it's 1/2 to the x quantity plus 3. So the horizontal asymptote for g of x is y equals 3. It's also a decreasing function because its base is between 0 and 1. And so the point of intersection is going to be above and to the right of where the two asymptotes intersect, which is at 3, 3. Now we'll want to think about entering f of x in the graphing calculator. It will be entered as log of x minus 3 divided by log of 1/2. We could also use natural logs. I chose to use common logs, and this is the change of base formula. So when I go to the graphing calculator, I enter log x minus 3, close the parentheses, divided by log 1 divided by 2, close the parentheses, and press enter. This takes us to the second function, and so we'll open the parentheses, do 1 divided by 2, close the parentheses, caret x plus 3. Now we'll go graph, or zoom, 6 for the standard window. And we see that in this view, the graphs don't quite cross because the log function became so vertical in the first quadrant. But if I move my cursor a little closer to where the point of intersection really is, I'm going to move it over to 2, 2, approximately. And now I'm going to go zoom 2 for zoom in and press enter. In this view, the curves do cross. Now I'm going to use second calc 5 for intersect, and I notice that I'm on y equals f of x that is only defined when x is greater than 3. So I have to move my cursor to the right until I get x larger than 3. But close to the intersection point there. I've got an asterisk showing up on the logarithmic function close to the intersection point. Now I'm going to hit enter, and now I see the second function, and I'm going to go a little bit to the right of the intersection point. I could go to the left and hit enter. Now it's asking me for a guess of the intersection point. I'm going to let the calculator do that work. And we see that the intersection point is at approximately 3.1, 3.1. It is on the line y equals x. The two coordinates are equal to each other. So now we'll get ready for a second example. I'll go to y equal. I will clear each of the functions using the down arrow in between. I'll also clear my key press history so that you'll be able to follow more easily. And we'll go down to the second function, where f of x is log base 3 of x plus 9, and g of x is 3 to the x minus 9. These graphs will have different shapes because our base now is larger than 1 instead of between 0 and 1. Here we have log base 3 and exponential base 3. So f of x is log base 3 of x plus 9. That's going to move our basic function 9 units to the left, and the vertical asymptote will be at x equals -9 for the log function. So the log function will appear something like this. G of x is 3 to the x minus 9, which is going to move the horizontal asymptote down to y equals -9. Here both f and g are increasing functions because the base is bigger than 1. And so we'll be having an exponential function. Sorry for that little glitch there. And this will be y equals g of x, whereas the original one was y equals f of x. Notice there are intersection points in the first and third quadrant, but we want the one where the x value is larger, so we'll be looking for this one here in the first quadrant. So we go to the graphing calculator, but first of all, let's note that what we're going to enter for f of x based on the change of base formula will be the log of the quantity x plus 9 divided by the log of 3. Common log in both cases, could use natural log. So I'm going to use the up arrow to go back to y1. I'm going to press log x plus 9, close my parentheses, divide log 3, close the parentheses, press enter. And then I'm also going to enter 3 to the x minus 9 for g of x. So 3 caret x minus 9. I'll go back to Zoom 6 for the standard screen. The intersection in the third quadrant is not going to show. because the logarithmic function became too vertical. But we've got one in the first quadrant that we're looking for. So I'm going to go second, calc, 5 for intersect. I'm going to move the cursor a little bit to the left on that logarithmic function and then press enter. And now the cursor has moved to the exponential function. I'm going to move, I said I was moving the cursor to the left, I meant to the right. I'm also going to move it to the right on the exponential function and hit enter. So I located the cursors close to the point of intersection. I'll hit enter one more time, and I'm getting the intersection point 2.19, comma 2.19. I'll enter it as 2.2, comma 2.2. And I'll continue in the next video.